this is my PC, my personal PC that I built. And I went a little bit outrageously overboard with all the LEDs. I've got just under 1,000 controllable RGB lights. So every little light is addressable RGB, and I can individually set and control each light. Okay, welcome to the Man World Boom. This is one of the episodes in my big computer upgrade or rebuild, where I'm going to be talking about the lighting. So I've got a pretty substantial, ridiculously overkill amount of controllable lighting in the computer. I went with Corsair because when I looked at all the different options, Corsair was the one that looked like it had by far the most controllable options and system-wide effects that you could do and individual effects that you could do. So I went with Corsair, and I really like their fans. I'll give you a detailed tutorial about how you can basically do the same thing. It's all very doable and pretty simple once you understand how LEDs and RGB work. So maybe let's just go over everything that I've got. I've got addressable RGBs in the water block for the graphics card and the CPU. I've got obviously the RAM, that's sort of nothing really you can do there. Then I've got addressable RGBs in the pump over here. I've got addressable RGBs in my distribution plate that I put in there. And then the fans themselves you can control. Behind the screen I've got the LS100 backlighting kit or whatever it is, but that projects sort of ambient light onto the wall behind the computer. And then I'm building a desk like this of the same wood with some channels inside, and I'm going to put this actual strip lighting under the desk. It's going to shine up into the channel. I think it's going to look really nice. And then lastly I've got some of these I don't know what you call them anyway, electric cables lighting up, power cable for the motherboard and the GPU, and every single light in this entire system can be controlled individually with their own effects or on and off or whatever you want. So maybe let me start off by showing you guys how an LED works. So addressable RGB has a 5 volt and a ground. It's got 3 wires going to it. It's got a 5 volt and a ground and a communication wire or a data wire. So if you look at your standard Corsair plug, there's 3 wires in there. Now the Corsair plug has a little pin on the side there, a little not a pin, like a standoff, and it's got a little arrow underneath it as well. So that's your positive, that's your 5 volt positive, and the one on the far other side is the ground, and the one in the middle is data. So if you look at the easiest way to look at it is on these strip lights. So maybe if we can zoom in on these things over here. So there you see there's a +5 over there, and there's a ground over there, and there's a data point over there. So you've got 1, 2, 3 wires coming out of this thing. A normal addressable RGB. Now the Corsair software is really powerful in the way you can control this, but what I had is I had to make quite a few hacks, because a lot of the EK product, for example, it's a single channel, and what you're looking for if you want to control more devices is you want an input and you want an output, because you want to basically, there's only 10 lights in this strip, but the basic controller can handle 60 lights, and the advanced controller from Corsair, the newer one, the LS one, can handle 192 LEDs. If you're only going to add a single strip to it, then you're only using 10 of the 192 addresses. That's ability. Corsair has a unique little plug that looks like that. And that's different to the standard RGB plugs that come on is there's two different types that I've seen. The one on the motherboard that's got the 4-pin where the one is missing. So it's basically a 4-slot thing, but it's got 3. And then there's a fat 3-pin one. And it looks like that. So there's your other one. It looks like that. This is the standard plug that comes on the EK product. So as you can see, it looks like that. It's got a one is missing, and then it's got 2 more. There's a little arrow there, the arrow indicating the positive, and then the opposite, the far one, is the negative, and the middle one is going to be your data wire. So when you connect these to your Corsair plug, then basically this is a little interface one that I made up. So it takes just to figure out where the wiring goes. But if I plug into there, I plug my positive in there, and Bob's your uncle. There we go. Now all the lights will come on again over there. So what I did, because I wanted to do quite a lot of controllable lighting, I immediately, when I picked up my first, what's it called? Lighting Node Pro, this one here. So when I picked this up, I opened the box up and I took a photo of the plug, because I saw on the internet that these are specific plugs and people don't find them, and so on and so on. I then sent that on to RS Components online. The guy was actually super efficient. He got back to me straight away, gave me the right part numbers. I then bought connectors that you can make up. So the problem is these pins that go into the connector, you can only buy, I think, in a roll of 100. So basically I've got 33 males and 33 females that I can make up of these plugs. So what you do is you decide whether you want a male or a female, and you just, crimp your new fitting. And then if you want to extend your light strip, you take a female fitting and you put it on the end of the wire. Obviously, like I say, the most important one is the data wire needs to come out. You can give it power, 5-volt and ground from anywhere, but finding it on the strip is quite easy, obviously. And then you need to take that data to the next set, and then you've got your light, your control carries on, through the one. So that's exactly what I did with the EK water block. So this is a 1080 Ti, and it actually came with RGB and not addressable RGB. So that's not addressable, individual light addressable. What I did is I just took off the little plate, took the little strip out. I put in a little light strip like this. I just put that in there and then soldered my wires on, my in and my out. And the other one, I then want to loop that channel. I want to loop around to the CPU as well. The controllers have obviously a limited amount of plug-in points. In fact, all of them only have 2. So the Corsair products I've got here, the Commander Pro's got 2 inputs. That's the same controller as the Lighting Node Pro. So it can handle 60 lights per channel. So it's 60 on one, 60 on the other. And also the effect that you set can only be on a single channel. I've got 2 channels on the Commander Pro. I've got 2 channels on the Lighting Node Pro, and those can each handle 60 LEDs per input. So I've already got 4 times 60. And then on the LS100, I've got, which is this big one over here. That's the box. So this is the one that goes behind the screen. They actually have quite a lot of LEDs in this little, or in these strips. That controller is now obviously a newer controller. And if you read here in the little manual, it says that it can handle 138 LEDs per channel, but only 192 combined. So one of the issues that I had was on the strip lights, to go all the way on the table and then back again, it was too many lights to control for the controller, along with the behind the screen lights. So when I enable the monitor on the screen, then the maximum amount of strips I can choose is 7. Now 7 lights didn't get me all the distance that I wanted. If the moment I disable the monitor lights, I then can control up to 9 strips of the LS strips at least, which is enough lights, but then I'd lose my screen lighting. I was stuck with this problem, and I thought for half a day, if I am going to buy another LS100 starter kit, because they're pretty expensive. So I didn't want to do that. All I need to do is basically create a splitter. What I then did is, because I make up my own plugs, because I've got all these plugs, I soldered a little male into a 2 female connector, soldered up all the little wires. See those? So now what I've got is a parallel running addressable RGB. So both of those 2 lights are going to be address 1, address 2. So I've plugged the LS, or these 2 strips, and my little splitter into the LS100 channel 1. So let me go to channel 1 here and add a lighting effect, rainbow wave. Let me just do something a little simpler. Well, we can stick to rainbow wave actually. On the Corsair software, you can choose the amount of lights, which lights you want to be active. So you can actually choose, say, light number 2, and as you can see, I can control 5 strips, so at least 7 strips if I wanted, but I actually only need 5 strips to cover the length of my table, and my effects are going to run parallel in both channels, up and down. So instead of having a loop around like what I initially had, I'm going to now have a parallel happening effect, which I actually think is going to look nicer than having the double effect. If I select, for instance, the first, whatever, how many lights that is, then you can turn those off. I can turn single ones on and off. So by control selecting, you can actually turn different lights on and off. It's amazing. The software is absolutely amazing. Super well done. I can highly recommend the Corsair lighting system if you can afford it. It's expensive. But the software is free there. You basically need, you can buy these LED strips for relatively cheap, and the plugs were super cheap. They were ridiculously cheap. And if you have one lighting controller, then you can start configuring things like this on your own. The simplest way to actually get your Corsair plugs is take these extension cables and just cut that off. There's a plug for you, and there's an extension plug for you. So if you cut these off and you solder them onto a lighting strip, then you can make up your own extensions and all sorts. So that's quite an easy way to just, get your plugs without having to go through the effort of what I did was actually buying my own plugs. All right, let me show you the other one that's really interesting as well. Bought these power cable lighting things. Don't actually know what they're called. Now, I had the same problem in that they came with the wrong plug, so I fitted my own little makeup plugs to them. But they have another problem in that I want to control both of them together. So I only have 6 channels to control. I've got the lighting node, the LS, and the Commander Pro. So I only have 6 channels that I can control. So I'm running out of things that I can control with my controllers. So I needed to double up. Plus, the other thing I want is when you have a sequential effect like visor and color wave, for example, you actually want them to follow each other. So if you put them on different channels, they're going to be different colors, and that's just going to look, well, it's not going to look as nice as it can. First, I put the plugs on them, but then I looked at, so if we go back to these LED strips, so the LED's got 4 little pins around it, and the one is the 5 volt, the other one's the ground, and the other one's the input address, and then the other pin is the output address. If you take a multimeter and you put it on continuity test or beep test, it's going to check whether this is connected to that. So if a wire is connected to another wire, it's going to beep. If you look at your LED, your input, there's a ground, there's a 5 volt, and there's a data input. So the ground, for example, is going to be connected to all of the LEDs. That's one over there, over there, over there. So they're all connected to ground. Same thing on the 5 volt. That's over there, over there, over there. So you can figure out which one of these pins are connected to the 5 volt. If you look at the data though, the data goes in over there, but it doesn't go in on the next one. The next one, the data has to leave from this one and go to the next one. So that pin over there is going to be your data pin, and that's going to go to that one over there. So basically on these LEDs, it goes from there, it goes in on that one, out from there, it goes to the next one's input. So they basically work on a +1 addressing system. So the controller is going to tell number 1 to be this color, number 2 to be that color, number 3, and so on and so on and so on. What I had to do with these things is I opened up this little plate over here and found the LEDs, and then I found the data pin on them, and I soldered a little wire, data wire on them. My primary input has got 5 volts and ground. I've got 2 wires, which the one goes into that one. The address wire from the primary goes into this first strip, and then I've got power doubling up across to the second strip, the second connector. But the data for the second connector I fetched on the LED. That's the last LED in this line. So basically what I've done, I've got 1 to 8 over here. Let me plug them in and I'll show you. It's actually quite clear then. So if I plug that in, and there we go. So if I turn them all on, that's number 7, that's number 8. So there I've got number 8 on. And now if I plug that one in over there, then number 9 is now the first one in this strip over there, and so on and so on. And so we go all the way across to there. There we go. So if I turn all of these on, I've got that. I think I've just got one too many. There we go. So where this is going to be helpful for me specifically is that when you do some of these sequential lighting effects, something like the visor effect, you can see it'll run across all the different ones, which can be quite nice because they're going to sit right next to each other and we're going to have this sort of effect. Something like the color wave as well. You see the color wave travels all the way across all of them. Yeah, I'm quite happy with getting that right and to work the way it does. Very good. This is my PC, my personal PC that I built. And I went a little bit outrageously overboard with all the LEDs. I've got just under 1,000 controllable RGB lights. So every little light is addressable RGB, and I can individually set and control each light. Actually run in parallel. So address number 1 is the same on each of these. So they actually run in perfect parallel. I can actually make them run in sets of 2, so I can double that. And the epoxy resin desk that I built with RGB in it also run in parallel. So whatever I do on the one does the same on the channel. So they run in perfect parallel. All right, so let me take you through all the lights that I have in my system. So from the basic stuff that comes with your normal water cooling kit. So the CPU water block's got addressable RGB, and that's standard EKW water block. What I did is I cut off the plug and I put in a Corsair plug because I've got all my lights controlled by the Corsair software, the IQ software. This water block, the GPU water block, also addressable RGB, but this came with still normal 12 volt RGB. Addressable RGB is 5 volt and it one data pin in between, in the middle at least. And this is an older card. It's a 1080 Ti. And basically what I did is I opened up the little strip at the bottom here and I put in a addressable RGB light strip, the same as what I've got in the light towers and the table. That's all the only place I've got them. But anyway, I put in my own little strip in there and now it's addressable RGB. I can control it. Corsair Vengeance RAM, I went for them because they're Corsair. If we go down here, the EKW water pump, same thing. I cut the plug off and I put it on the Corsair system. So now I can do all the Corsair lighting effects with it. This is probably my favorite out of all of them. It's light ribbon cables. And again, that's actually quite an interesting one. So I cut the cable, put a Corsair plug on it. But then in order to get the data to sequentially roll on to the next one, you need to get the data pin off the last light. So from the 2, one of them was more accessible than the other, and that's why I soldered on. So I actually soldered on to the little LED pin, which is incredibly tiny, and I'm really chuffed that it came out real nice. So anyway, so I brought the address line, the data pin out, and I gave it power from the other pin as well, from the input power to the one cable. And so both of these basically plug in sequentially into each other, and then works, as you can see, works great. And then over here I've got a custom distribution plate. So this has got LED strips all around it, basically projecting light into the distribution plate plexiglass, which is basically exactly the same thing that's happening in the CPU water block. Fans, at least, these are the QL120 fans. They've got the inner and the outer light loop, and then they've got the same again on the back. So it's a double light loop. So basically, there's quite a lot of LEDs inside these fans. I've got the Corsair LS100 controller, which is mounted over there, and that's got this ambient light on the back of the screen. I've got this effect set up now. I think this is called color wave, I think. This little controller, so this is the one channel. The other channel is controlling my lights in my table. These are light strips that run in parallel. So whatever I do on the one happens on the other, and it's controlled by the LS100 controller. This is also quite a great place for me to show you all the different lighting effects and how cool the Corsair software actually is and what you can do with it. Moving along to this area here, I've got the keyboard. I decided to upgrade my keyboard as I was busy with this build because the Gigabyte keyboard that I had was actually incredibly frustrating. So I was kind of in the market for a new keyboard anyway. So I thought, okay, let me just throw caution to the wind and go for the Corsair K100, which is the new light sensor, whatever, OPX keys or whatever. It's got a light, it's light sensor that breaks under the keys when you do it. So it's supposed to have 0 debounce. I've got absolutely no complaints. It's been working absolutely perfect, and it's really taken care of all my frustration I had with the previous keyboard. And then the same thing for my mouse. The mouse I had was quite a budget gaming mouse, and the extra buttons didn't work. So I thought, okay, let's again throw caution to the wind, and I bought a Corsair wireless mouse. Oh yes, and the light towers. I suppose that's the next one. So the light towers I built myself. They are giant light towers, as you can see. In the episode on the light towers, I do go over them in depth, and obviously you've got a whole build montage of how I built them. But they've got lights all the way up the tower, and then also I've got, I think, 11 lights in the base. If I put them on the table, then it's too much clashing of lights between the table lights and the tower lights. So at the back there, they actually work really well. This whole setup, the way it is now, I think is pretty ideal for how I want to put it in my next office.